Introduction to Kubernetes. Kubernetes has revolutionized the modern IT infrastructure by providing a robust platform for automating the deployment, scaling, and management of containerized applications. Its ability to manage complex workloads with efficiency makes it an indispensable tool in today's cloud-native environments, ensuring applications run smoothly across any number of computing environments. Understanding Kubernetes architecture begins with grasping the roles of master nodes and worker nodes. Master nodes act as the control plane, managing the cluster's state and configuration, while worker nodes run the actual applications. Key components like pods, services, and deployments work together within this architecture to ensure applications remain resilient and scalable. Setting up your first Kubernetes cluster may seem daunting, but it's a critical step in leveraging Kubernetes power. Beginning with choosing the right environment for your cluster, whether on-premises or in the cloud, you'll proceed to install the Kubernetes software and configure your nodes. This foundational setup paves the way for deploying containerized applications. Navigating the Kubernetes dashboard introduces a user-friendly, graphical interface for managing your clusters. This web-based UI allows users to deploy containerized applications, monitor cluster resources, and troubleshoot application performance issues. It's an essential tool for those who prefer a visual approach to cluster management. Deploying your first application on Kubernetes is a milestone in your DevOps journey. Step by step, you'll package your application into containers, create deployment configurations, and launch your application onto your Kubernetes cluster. Watching your application go live is a rewarding experience that underscores the power and flexibility of Kubernetes. Managing pods and containers is fundamental in Kubernetes, serving as the primary structural units in any cluster. Pods encapsulate one or more containers, ensuring that they share resources and are scheduled together. This setup is crucial for creating tightly coupled application components that need to work in unison, enhancing both efficiency and scalability. Scaling applications in Kubernetes is streamlined, allowing for dynamic adaptation to varying loads. This is achieved through replicating pods across multiple worker nodes, ensuring high availability and fault tolerance. By monitoring application performance and automatically adjusting the number of pod replicas, Kubernetes enables applications to meet demand without manual intervention. Kubernetes revolutionizes service discovery and load balancing, automatically assigning a unique IP address to each pod and a DNS name for a set of pods, simplifying inter-service communication. Load balancing distributes network traffic across these pods, ensuring no single pod is overwhelmed, thereby maintaining application performance and reliability. Configuring persistent storage in Kubernetes is resolved with volumes, offering a way to store data beyond a pod's lifecycle. This is pivotal for stateful applications that require consistent and reliable storage, independent of pod life. Kubernetes supports various storage solutions, ensuring flexibility and resilience in data management. Kubernetes namespaces provide a powerful mechanism for isolating resources within the same cluster. This allows for multiple teams or projects to operate within the same physical cluster without interference, offering an effective way to manage resources, control access, and streamline cluster organization. Namespaces ensure a clean separation of concerns, enhancing both security and efficiency. Automating deployment processes with Kubernetes deployments revolutionizes how we deliver applications. By defining the desired state for our applications, Kubernetes adeptly manages the transition to the new state without downtime. This automation simplifies updates, scaling, and rollback processes, ensuring our applications are always running optimally and reducing the manual workload on developers. Leveraging Kubernetes stateful sets is essential for managing applications that require persistent storage and unique identifiers. Unlike stateless applications, stateful ones remember their data and state across restarts, making stateful sets perfect for databases or any service where the data or state needs to be preserved. This capability facilitates more complex deployments, maintaining order and uniqueness. Understanding and utilizing Kubernetes daemon sets ensures that some pods are automatically run on each node in the cluster. This is particularly useful for deploying node-level utilities, such as log collectors or monitoring agents, ensuring that these critical services are uniformly distributed across the cluster and always available. Managing application configurations can be tricky, but using config maps and secrets in Kubernetes provides a streamlined solution. Config maps allow you to decouple configuration artifacts from image content to keep containerized applications portable, while secrets provide a secure way to store and manage sensitive information, such as passwords or API keys, reducing the risk of exposure. Implementing network policies in Kubernetes is akin to having a built-in firewall for your applications. It controls the flow of traffic between pods, ensuring that only the intended communications occur. This level of control is invaluable for enhancing the security posture of your applications, protecting them from unwanted or malicious access within the cluster. Setting up and managing Kubernetes ingress allows external traffic to reach the services within your cluster efficiently. This critical component acts as a gateway, directing incoming requests to the appropriate services based on predefined rules, making it easier to expose your applications to the internet or internal networks securely. Monitoring the health and performance of your Kubernetes cluster is essential for ensuring its reliability and efficiency. By leveraging Kubernetes native tools and third-party solutions, administrators can gain valuable insights into resource usage, potential bottlenecks, and system health, enabling proactive management and swift resolution of issues before they impact service delivery. The implementation of auto-scaling in Kubernetes enhances the efficient utilization of resources by automatically adjusting the number of running instances based on demand. This capability ensures that applications remain responsive during peak times while conserving resources during periods of low demand, optimizing both performance and cost. Managing cluster access and security is paramount in maintaining the integrity and confidentiality of your Kubernetes environment. Utilizing role-based access control (RBAC) allows for the fine-grained assignment of permissions, ensuring that users and services have only the access necessary to perform their functions, thereby minimizing the risk of unauthorized access or actions. Utilizing Helm charts simplifies the deployment process in Kubernetes by packaging applications and their dependencies into a single, manageable unit. This approach streamlines application distribution, versioning, and management, enabling developers and operators to deploy complex applications consistently and efficiently across various environments. Kubernetes operators are game changers in automating application management, enabling software to actively manage resources in a Kubernetes cluster. They extend Kubernetes capabilities, allowing for the automation of complex applications through custom resources. This innovation streamlines operations, ensuring applications run efficiently and reliably without manual intervention, making it a cornerstone for modern IT deployments. Implementing backup and disaster recovery strategies in Kubernetes safeguards against data loss and service interruptions. With the dynamic nature of containerized environments, traditional backup methods fall short. Kubernetes offers robust solutions that ensure data persistence and service continuity, essential for maintaining the integrity and availability of applications in the face of unexpected failures. Advanced troubleshooting techniques for Kubernetes clusters are vital for maintaining operational efficiency. As clusters grow in complexity, identifying and resolving issues becomes more challenging. Leveraging logs, metrics, and Kubernetes built-in debugging tools, operators can quickly pinpoint problems, from pod failures to network issues, ensuring smooth and reliable cluster performance. Kubernetes Federation elevates cluster management by enabling the coordination of multiple clusters across different environments. This approach simplifies global deployments, providing a unified interface for managing resources, ensuring consistency, and optimizing application availability. It's particularly beneficial for achieving high availability and disaster recovery across geographically dispersed data centers. Integrating continuous integration, continuous deployment, CI/CD pipelines with Kubernetes streamlines the development and deployment processes. This integration enhances automation, allowing for faster and more reliable application updates. By leveraging Kubernetes dynamic environment, developers can focus on building features, while the platform ensures that applications are deployed efficiently and consistently across various environments. Securing your Kubernetes cluster is paramount in safeguarding your IT infrastructure from potential breaches. Best practices and tools are essential for enforcing security measures. Implementing role-based access control, network policies, and using security-focused tools like Aqua Security or Twistlock can significantly enhance the security posture of your Kubernetes environment, ensuring that only authorized users and services can access sensitive resources and data. Optimizing resource allocation within Kubernetes not only ensures efficient application performance but also reduces costs. By setting quotas and limits, administrators can prevent any single application from consuming disproportionate resources, thereby maintaining the stability and reliability of services. This approach facilitates a balanced distribution of resources, promoting an environment where applications can perform optimally without straining the infrastructure. Leveraging custom resource definitions, CRDs, empowers developers to extend Kubernetes capabilities, tailor-fitting it to their organizational needs. CRDs allow for the creation of unique resources, making Kubernetes more adaptable and better suited to handle specific tasks or applications. This flexibility is key to evolving Kubernetes environments, enabling them to support a wide range of applications and workflows. Understanding the Kubernetes service mesh, particularly with tools like Istio, offers enhanced control over service-to-service communication within microservices architectures. This includes capabilities for traffic management, security, including encryption of service communication, and observability. Istio's service mesh provides a powerful layer of infrastructure, making it easier to manage complex microservices interactions, ensuring high availability, and securing communications without requiring changes to the application code. Implementing GitOps workflows with Kubernetes introduces a version-controlled way to manage cluster configurations and applications. By treating infrastructure as code, teams can improve deployment reliability and speed. GitOps automates the deployment process, leveraging Git repositories as the single source of truth for declarative infrastructure and applications. This method simplifies rollback, enhances security, and streamlines collaboration among development teams, paving the way for more consistent and efficient operations. Exploring multi-cloud Kubernetes deployments offers unparalleled high availability and disaster recovery benefits. By spanning clusters across multiple cloud providers, businesses can achieve a robust infrastructure that mitigates the risk of provider-specific failures. This strategy ensures that applications remain accessible, even in the event of a major outage in one cloud environment. Managing dependencies with Kubernetes package management streamlines application development and deployment. By utilizing tools like Helm, developers can define, install, and upgrade even the most complex Kubernetes applications. This approach simplifies the management of the software stack, ensuring consistent environments across development, testing, and production. Understanding the Kubernetes API and creating custom resources opens the door to tailored solutions that fit specific business needs. Through custom resource definitions, CRDs, organizations can extend Kubernetes capabilities, creating bespoke resources that behave like native Kubernetes objects. This flexibility enables the development of specialized services and applications. Leveraging Kubernetes for AI and machine learning workloads transforms the way organizations handle data-intensive tasks. Kubernetes efficiently manages the resources necessary for training and inference, allowing for scalable and resilient AI models. This capability facilitates rapid experimentation and deployment of machine learning models, accelerating innovation. Kubernetes and IoT managing edge computing workloads signify a revolution in handling vast amounts of data generated by IoT devices. By extending Kubernetes to the edge, businesses can process data closer to its source, reducing latency and bandwidth usage. This approach enhances real-time data analysis and decision-making in IoT applications. Migrating legacy applications to Kubernetes presents a unique set of challenges, yet offers transformative benefits for scalability and agility. This process involves containerizing traditional applications, creating a bridge between classic architectures and modern, microservices-based approaches. Successfully navigating this shift can significantly enhance an organization's deployment speed and operational efficiency, marking a pivotal step in digital transformation. Kubernetes governance is crucial for maintaining system integrity and compliance within dynamic container environments. Establishing clear policies and governance frameworks ensures that deployments are secure, efficient, and in alignment with organizational standards. This approach not only mitigates risks but also fosters a culture of accountability and continuous improvement across development teams. Managing costs effectively in Kubernetes environments is essential, as the dynamic nature of container orchestration can lead to unexpected expenses. Through diligent monitoring, right-sizing resources, and employing auto-scaling capabilities, organizations can optimize their cloud expenses. This proactive approach to Kubernetes cost management ensures that resources are utilized efficiently, maximizing the value of cloud investments. Building a DevOps culture with Kubernetes facilitates collaboration, enhances speed, and improves reliability in software development and operations. Kubernetes streamlines the CI/CD pipeline, promoting a culture of continuous improvement and fostering a more collaborative and efficient operational model. This cultural shift is fundamental for organizations aiming to thrive in today's fast-paced digital landscape. The future of Kubernetes is marked by continuous innovation, with trends pointing towards enhanced security features, simplified management interfaces, and more robust multi-cloud support. As Kubernetes evolves, it will further solidify its role as the backbone of containerized environments, driving the adoption of cloud-native technologies and shaping the future of software development and deployment. Hope you liked the video. Do share your views.